Hi, Wheaton North. This video is going to review some basics about bonding that we covered first semester and introduce Lewis dot structures. So, first review. We need to remember the definition of a covalent bond. During Unit 7, we're going to be focused mostly on covalent bonds. Are covalent bonds when a non-metal atom steals an electron from a metal atom to create positive and negative ions, or is it box B? Non-metal atoms share electrons because neither one of them has a strong enough electronegativity relative to the other one to steal it. Hopefully you answered the second box, box B. Covalent bonds between two nonmetals. They both have a relatively strong electronegativity, and they're going to be constantly fighting over their valence electrons to try and fill it up. Second question, which box best illustrates that covalent bond where they're fighting constantly or sharing electrons? Is it box A or box B? Box B was correct. When they're sharing electrons, it creates this hybrid electron cloud. These two electrons are going to zoom around both nuclei and create that hybrid electron cloud that creates the bond. This picture is showing the electron from sodium joining the chlorine to give it a negative bond, and the sodium becomes a positive, and then they become attracted. They're two separate things, and they become attracted because of their charge. All right, last review. How many valence electrons does carbon flashing there? We know that it has 4 because it is in the 4th column of the periodic table. So in your notes, first thing to write down. You can easily determine how many valence electrons an atom has by figuring out what column it is in the periodic table. And remember, we ignore the middle columns when we don't count those. So that is going to be a very important skill for what we're doing the rest of this video. All right, Lewis dot structures are two-dimensional illustrations or drawings of atoms. Atoms and molecules are three-dimensional, but we're going to attempt to represent what's happening on the two-dimensional paper. And what we're going to highlight are the valence electrons that each of the atoms have, and use that to figure out how they're bonding and help us predict their shape later on this unit. When we can predict their shape, we're going to be able to figure out how they interact with other molecules, which is our ultimate goal. All right, so how do we figure out Lewis dot structures for atoms? These are the rules. You need to write them down in your notes. Rule number 1, write the element symbol. So what I have here is an X. You would put an H or an AR for argon or a P for phosphorus. Whatever element you're doing, you're writing their symbol down first. Then you need to look on the periodic table and figure out how many valence electrons it has. Each dot that you draw is going to represent a valence electron. When we put these valence electrons down, we're going to pretend that there's like this invisible box around the symbol, and we're going to place the first 4 electrons on each side of the symbol. So if you had 1 valence electron, if you're in the first column and you have only 1, you just put 1 dot. And honestly, it doesn't matter what side of the box you start on. We just traditionally use a top, but you don't have to. So any side of the box, you have 1 dot representing 1 valence electron. If you're in the second column with 2 valence electrons, you put 2 dots. They're going to be, because electrons repel, the first 4 dots are going to repel each other and be on opposite sides of the box. If you have more than 4 valence electrons, then they will be forced to pair up. So the 5th one pairs up, the 6th one, the 7th one, and then if you have 8 valence electrons, if you're in the last column, all of them are paired up. That's how you do it. That's it. One other thing we're going to be looking at is bonding. Remember that atoms bond to fill their valence energy level. Usually, you're going to end up, however many valence electrons you start with, after you bond with other atoms, you're going to have a full valence energy, and usually that means 8. There's going to be some exceptions to that, which you'll see in some of the examples that we're doing in a second. One of the things that we use is when you have electrons that are by themselves, they're not naturally paired up on their own. Those are the electrons that are going to be involved in bonding, and the whole point of bonding is basically to pair them up. And we can predict, this is a big sentence right here, write this box down in your notes. You can predict how many bonds an electron can form by figuring out how many lone electrons it has. You can figure out how many lone electrons it has by making the Lewis dot structure for the atom. Okay, let's go through a few examples. Hydrogen is in column 1, so it has 1 valence electron, and you can put that dot on any of the 4 sides. How many single bonds can hydrogen form? It's got 1 single dot. It's going to try and pair it up. It can form 1. Phosphorus is in column 1, 2, 3, 4, 5. It has 5 valence electrons. You're going to draw it like this. The first 4 go on opposite sides, and then the 5th one pairs up. How many single bonds can phosphorus form? 3. It's got 3 lone electrons that are going to try and pair up when they bond. Calcium is in column 2. Its 2 valence electrons are going to go on different sides. Now remember, electrons are negative and they repel each other. So this is an okay way, completely acceptable way of writing this Lewis dot structure. This is better. They're going to repel to be as far away from each other as they possibly can. How many single bonds can calcium form? It's got 2 electrons. They're both single. They're both going to form bonds. Argon is in column 8. It has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. How many single bonds can argon form? None. It doesn't have any single unpaired electrons. If you remember, it belongs to the noble gas family, which we called inert. They're non-reactive, and the reason is because they don't need to react to fill up their valence energy level. All right, chlorine, column 7, 7 dots, 1, 2, 3, 4, 5, 6, 7. How many bonds can it form? 1. Not 7, 1. It only has 1 electron that still needs a pair, so it's going to form and try and steal electrons or share to fill that space. All right, aluminum, 1, 2, 3, because it's in the 3rd column. It can form 3 single bonds. It has 3 to pair up. It's going to pair up all 3. All right, let's see if we can figure this out. Which Lewis dot structure is correct for hydrogen? This is a trick question. All of them are correct. It doesn't matter what side of the box you put the dot on. What's correct for phosphorus? How many dots should phosphorus have? First of all, should it have 5 dots or should it have 3 dots? It should have 5. And remember, we keep them separate until they have to be paired up. So number 1 is correct. What's the correct Lewis dot structure for chlorine? It should have 7. So this one is wrong. The 7, we want to distinctly show pairs, not have them all spaced out. So this is the part where being neat when you're doing this is kind of important. You need to make sure they look like they're paired up. So it's easy to identify that this has 1 lone electron and it would form 1 single bond. All right, hopefully that all made sense. Don't forget to submit your homework the way your teacher wants. And if you have any questions, ask them in class tomorrow. Have a great day.